All right, well, thank you to everybody that made it to this session. This session we'll be talking about debugging PowerShell and VS Code. If you haven't switched your PowerShell editing experience to VS Code, this might be the tipping point for you. So let's dive in. So I'm first going to try to show you or tell you why you should invest in learning debugging, and not only debugging with the right host messages and right output messages, but by using the debugger in an IDE such as VS Code. The first reason is you already spend a lot of time debugging, whether or not you realize it. You spend a lot of time typing variables into the command prompt to see what they return, and you spend a lot of time debugging your scripts by taking sections out of your functions and running them independently. And so you're already spending a great amount of time debugging, and so why not be more efficient at it? The next is there will always be bugs in your code, and they're not, as your code base grows, it's going to be harder and harder to find those, and that's where the debugger really shines, as we'll see throughout this the demos in this presentation. And poor debugging skills lowers your productivity. When you're working with a wider, I guess, a much more verbose coding base, it's going to take you a lot longer to find those bugs if you don't use a debugger. Many hours, development hours put into developing a debugger program that would help you sift through different functions and modules and get an idea of what the state is inside the function while it's running versus having to extract out parts of that code and run it independently. The next one is being a good debugger makes you a better developer. A lot of people in the IT operations won't claim the title of developer, but if you're writing PowerShell code, you are a developer in one sense, and you might as well strive to be a better one. And so why not learn debugging? And the last one is debugging is sometimes the only way to validate your expectations. So like I said before, when you have a larger code base, there's just certain things that you won't be able to pull out. There's variables that are going to be changed inside your code base that you can't see unless it's at runtime. And that's where the debugger will let you pause the code, go inside the code, and see what's actually happening when the code is running versus just having to debug from the output, which can be very, very troublesome. So next I'm going to talk about the process, the high-level process of debugging. The very first step is you need to build a mental model of the expectations. We need to understand what the code is trying to do. And so we need, if you've written the code, then it's easier. But if you haven't, you have to read the code base to at least understand what the commandlet or the function is trying to do. And that's the first step. The next step is identifying and analyzing the bug. So usually this could be an error message, or sometimes it's just unexpected behavior where it doesn't return what you would expect it to. The next step is to correct the code. So we'll ultimately open up the code base, the function, or the module, and we'll make some changes to correct that bug. But then the last step is we need to validate that change. So that usually involves us rerunning that code base. So there's really two types of debugging. I think there's three. Yeah, so there's visual, at least in my mind. There's visual debugging and IntelliSense. So if you misspelled a variable or something like that, IntelliSense in VS Code will pick it up. But we also spot check. We spot check to make sure that we're using the right commandlets and we're using the right parameters. And that's all visual debugging and IntelliSense for the most part. The next is system output. And this is where a lot of IT operators kind of stay with their debugging, is they solely rely, because PowerShell is an interactive language, on that system output. I'm going to type in the terminal the variable to see what it is in the script. And this works very well for scripts. And debugging has mute benefits over system output when you're working with scripts. But as soon as you go to functions, this is where the next method shines. And that's the debugger program that we're going to be spending this entire talk talking about. So first, I kind of want to go through the high level of what we're going to do in the demos, and then we'll jump right into it and keep the PowerPoint to a minimum. The first concept that I'm going to introduce you to is the concept of breakpoints. There are three types that I'll talk about. There are line breakpoints, where you just say, hey, I want to break on this particular line of the code. There are function breakpoints, so you can declare, okay, I want to break every time write host is mentioned, or maybe a particular commandlet that's setting a function, you want to break right before it so it doesn't actually invoke the set. And then there's conditional. So if you're running through a loop, you want to break, maybe you're only having problems on the 10th run, and so you want to break on the 9th or right on the 10th run of your code. And so that's where conditional breakpoints would come into play. After I've introduced the breakpoints, we'll spend a little bit of time just navigating the debugger. We'll go through the debugger panel itself in VS Code and the different actions that you can take in the debugger. And then we'll talk about the difference between single file debugging versus workspace debugging in VS Code. Really, the main difference is single file, you can do it without any predefined settings, and then workspace, you can get pretty fancy and you can change the way the VS Code attaches to your running terminal, so your integrated terminal versus a different process, or you can even have it invoke custom scripts whenever you enter the debugger. Then we'll dive into debugging in action. We'll take a look at debugging a script in PowerShell, a function, and then a module. And the last thing is I'll give you a little introduction to debugging with Pester. And this will make a lot of sense when you're debugging modules in particular, and you're trying to validate their expectations, and they're complex and they're very plentiful. There's a lot of different operations that you want to test in a module when you're working with your different functions. So that is the end of the PowerPoint. So before I dive into this, I'm going to go ahead and deploy a stack to AWS, and I'm going to create basically a Windows 2019 web server. And if no one's familiar with CloudFormation, basically this is all a bunch of fancy stuff to say that I'm going to create an EC2 instance, basically a VM in the cloud, and then I'm going to run these PowerShell commands. That's all in its entirety what the stack is going to do. I'm going to install the web server role. I'm going to install the web management tool so I can get into IIS. I'm going to install Chocolate, and then I'm going to install VS Code so I can show some debugging on a module with that. So I'll go ahead and import the AWS module, set up my credentials, set my region, and then some variables. I'm going to make sure that my bucket exists and that I'm authenticating to AWS. And then I'm going to write that file to my bucket. So I just basically uploaded my template to S3, and I can verify that by pulling this down and looking at the timestamp and then the actual key name. Next, I'm going to define the template. So the template, the template URL is a combination of the S3 URL and then the file name. So I'm just going to define that here. And then I'm going to go ahead and deploy a new stack. So this new stack is going to go out and it's going to use CloudFormation to build me a new web server for the purposes of this demo. And I did pray to the demo god, so hopefully this will work. And it doesn't. So now at this point, typically I would just start tearing apart my script and trying to figure out what's going on. But instead, I'll set a breakpoint here and I'll hit F5 to enter the debugger. And we'll stop right on that line 19. So this is a line breakpoint. And really what I want to figure out is, why did I get access denied? And typically what I would do inside of a script is I would start to validate my parameters and the variables I'm passing to those parameters. And if you actually look at the template name, if you highlight over the template parameter, you can see that it has .yaml.yaml. And so here's just the power of the debugger itself, where you can pause the code at a point in time, and you can actually look at the variables. Now, since this was a script, it would have been pretty easy just to go to the terminal and type $template URL, and it would have outputted the same operation. You can see that down here. If I just do, get down in the terminal, I could have seen it that way. But it becomes way more complex when we start to deal with functions. We'll just go in sooner. But this does a great job of just highlighting the power of the debugger and how I can see all my variables on the left, and I can pause my code. So what I'm going to do now is I'm going to stop this debugger. I'm going to fix my variable, and then I'm going to go ahead and redeploy my stack. And I'll just look in AWS and make sure that I've got a web server deploying so that it's ready. Okay, so we're in progress, and we'll move on. So I'll kind of pause here for just a brief second in case anybody has any questions. And then we'll dive into more debugging. All right. Okay, cool. So what I'm going to do here, this is actually a debug test file that comes with the PowerShell extension. So if you, let's see here, where's that file? So on the Mac, it's here. It's under the profile context, I think under roaming in Windows. But basically, it's in this path. You can Google for it to open it up. But it's a really great debugging file that will walk through the different exercises that we can do. So the very first thing that I'm going to do is just kind of walk through the code. So it has a parameter that it has a count of 50 by default, and then a millisecond delay in milliseconds of 200. And then there's another function called writeItem, which takes in the item count, and then basically goes through a while loop and outputs some stuff and then starts a sleep timer. And then there's the do work that writes output, calls that particular function, and then writes host to done when it's completely done. And then at the very end, it calls that function. And so what we'll do is we'll place a line breakpoint. And to do the line breakpoint, you can either come over here to the left of the number line and just click, or you can actually just click on the line and hit F9. I'm typically more hands-on keyboard than I am on the mouse, so I use hotkeys a lot. And one caveat to the single file debugger in VS Code is the file does need to be saved to disk. So if you have an untitled document of some ad hoc PowerShell, it's not going to run the debugger when you hit F5. It does need to be saved. It actually does need to be called. So like say you're debugging a function, you would have to run the debugger from the file that's calling the function, not the file that the function's in. And that'll be more relevant in a second. So now that I have that there, I'll just enter the debugger by hitting F5. We'll see if it starts. Maybe I did a wrong. Oh, I need to go up here. Set the right part. Maybe not. Let me restart my PowerShell session. There we go. Okay, just need to restart my session. Sometimes it is a little glitchy, so watch out for that. So right now, what I did was I put a line breakpoint. So the first time that hits this line of code, it is going to pause. So at the very top, we'll talk about the actions first. So the actions that you have available are the continue, which is F5. And what this will do is it'll continue on until it hits that breakpoint again. So if I were to hit this right now, you can see that my I is 1. And we would expect if this is just counting incrementally up to 50, it looks like by default, it's going to stop again on 2. So if I hit play, it's going to go run through the whole code logic again until it hits 2. The next action is step over. So step over would simply just step over this line of code to the next. And if I do that, it'll go to start sleep. And you can actually step into these. So if you wanted to see the code that's behind start sleep, you could step into that. This is very useful if you're debugging a module that has private and public functions, and there's an error inside the private where you would want to step into additional functions that's being called from the module. And then you can step out too. So if I want to step into start sleep, and I was like, oh, that's too far. I do that all the time where I kind of go into like the one GetModule and get very confused, and I have to pull myself out of that module, and then I would use the step out. So just to go over that too, like if I wanted to step over this again, it's actually going to go bring me back up to the next iteration of this where I'm at 3, because it's now inside the next step of that while loop. And then I can step into the while loop. If I were to just hit step over, it would step over that to number 4. So if we step in, we're going to see the output change to 3. And we can step in again, and then I is going to change as well. If we step over I again, it'll change to 4. And then it'll start the sleep timer. And that, in a nutshell, is the line breakpoint, and then kind of the actions that you can take in the debugger. So there's a few different types of breakpoints that I mentioned before. There's a line, which we just used, and then there's a function breakpoint. So if we want to create a function breakpoint, let me bring breakpoints to the top of the panel. There's a few ways you can create one, and then you can edit it, or you can come over here and you can click the plus sign next to the breakpoints. And then it defaults to a function breakpoint, or a function to break on, and we'll break on that custom function in the script called the writeItem. So the very first time that writeItem is called, it should break. If I hit F5, it broke right on the first call from do work into writeItem. And you can see that it did that as the function was being called itself. and it doesn't even have any variables populated yet. So if we step into that function, we'll start to see the variables be defined. So that's useful if you know that a particular commandlet is throwing an error, but you don't know what line it's on, or you want to break on, like most commonly what I'll use this for is set commands, or I want to break right before it sets anything, or I can put a what if on the statement itself as a parameter. So that is a function breakpoint. And the last one that we'll talk about here briefly is a conditional. So to create a conditional one, you want to hover over to the left of the number, right-click, and add conditional breakpoint. Now, the expressions in here is simple PowerShell logic. So we would do $i equals 10. And that's just an expression. So when I on this line equals 10, we're going to break. This has been very useful for me when I've been debugging code that has several loops in it and loops within loops, and I want to break on a particular set just to test the functionality. I want to break whenever the loop's gone through 3 times or 4 times, or maybe the issue happens on your 100th try, and you don't have a good way of getting into that conditional breakpoint. If you were to use the line breakpoint, you would be hitting play or continue 99 times to get to that 100th run. So we'll go ahead and just hit F5, and we should break right as the output variable. Well, never mind. What did I do wrong there? Do I have to do EQ? I forget the condition here. Maybe it's EQ. Yeah, okay, so it's EQ, not equals. So if you can see over here, we got the item count, which came in at 50, and then the I equals 10. So that's one way that you can use conditional breakpoints. Let me look at my notes real quick. I think yep, covered all of it. So the last thing I want to talk about when we enter this is there's different variables over here that we've seen. The auto is just what the code editor thinks is going to be the most valuable to you, but then you can immediately jump to the global script and local variable sets, which is very useful if you're using global variables inside your PowerShell code. It also, like we had briefly talked about, mentions the breakpoints that you can have. So you can have multiple breakpoints. We could have used all 3 in combination. We could use a conditional, function, and a line breakpoint if we needed to. So that way we could break at different points in the code if desired. Watches we won't get into, but there's a way that you can watch for a certain condition to happen, and then call stacks is actually just showing you where the code is run from. So like write item was actually called from do work, and do work was actually called from inside the script block, which was on line 28 here. And it even gives you the line number that those things were called upon, which is very helpful as well. All right, so let's go and see if my stack has been created. It's done. All right, looks like we got a running EC2 instance, which is cool. So this is part of what Joe was talking about earlier. It was kind of an excuse for me to experiment with the AWS PowerShell module for this presentation. So thank you all for that. I learned quite a bit. I went ahead and created a simple function in PowerShell that combines a couple commandlets in the AWS module. So like I said, there's a stack that kind of creates the infrastructure, but the stack also includes all the resources you need. So in this particular one, I have a security group that allows our RDP access. And I also have an EC2 instance, but I wanted to know stack information and the EC2 instance itself combined in kind of one commandlet. So I wrote this custom function, and it takes 2 parameters. It takes the stack name and this logical resource ID. That is actually just whatever you called the resource in your CloudFormation template. So in this case, mine is EC2 instance. And since I'm on Linux, everything is case sensitive, and that's still a struggle. But I'll digress there. So inside here, with those 2 parameters, it gets the stack status. So usually it'll be in progress, or it'll be created, or it'll be deleted typically. And so I wanted to know the status of the stack, but I also wanted to know the instance. I can get the instance ID of the EC2 instance from the stack as well. And then from that information, I can actually determine the properties of the EC2 instance of the VM that's running up in AWS. And so that's what I'm doing here. So I'm getting the instance ID in the stack status, and then I'm getting a bunch of the properties from the EC2 instance and creating basically a custom object here that'll be returned to me. So I can have kind of a holistic state of the stack in the EC2 instance that I was operating. And so I'll go ahead and run this, load it into memory. And then I'm going to copy the function down here. Just give it a stack name, simple win stack, and the logical identifier. Resource ID is EC2 instance. Oh, looks like so got to load in the module first because I restarted my session, remember. So let's go back, give this another try. Okay, so as you can see, that's working a little bit better now that I can connect to AWS. But I get my stack name and I get my status, it's complete, which is awesome. And I get my instance ID, but none of the properties are coming through for the EC2 instance itself. And that should all be coming from this particular variable. Now, typically what I would do here without the debugger is I would kind of tear this function apart. I'd rip off the param block and I would statically assign the parameters, and I would basically undo the work that I just did to convert it from a script to a function. And that's how I would do it with system output, as I'd had to figure out, okay, what's going wrong with line 11? Why is this call not returning the proper objects? What is EC2 instance defined as when the code runs? And this is really the power of the debugger, because now I can come in here and I can create a breakpoint on that line. Let me remove all my other breakpoints and reset that. And then hit F5 to go into the debugger. So now it's run in there and it's run the get stack information and the resources. And I can see that if I just hover over the variables, I can see the value. So the very top part, it says create complete, value create complete. I can even come over here and I can see the stack name and stack status. If I expand that, I can see the value that it returned. Inside instance ID, I can see the same thing. But then inside the EC2 instance, since I stopped on that line, it's not defined yet, I'll just quickly step over it and let it define that particular variable. And when I look at this variable, this isn't what I expect. I expect to see some private addresses. I expect to see the public IP address, the platform, the operating system, and it's not there. I get an owner ID, requester ID, and so forth, and group names, which I don't know what those mean. But if I expand instances, I can see that the first instance, I can drill down a little bit more, and I get a slew of properties. If I come down a little bit more, I should start to see, oh, platform, Windows. That was one of the options I wanted. And so what I'm doing is with this call is I'm not going far enough down the stack. I actually need to just capture out the instance returned from this particular commandlet, not in its entirety. And so what I can do is just use a sub-expression. I think it's instances. And then I'll just stop the debugger because we've already defined that variable. So if I let it run, it's going to just show me what it showed before. But now I'm going to go ahead and move the breakpoint a little bit farther down to return, just like right before it actually returns the output from the function. And we'll go ahead and we'll take a look at these instance properties. So if we look at instance 0, we can see it's now defined in that variable all these values. So now it'll make sense when I'm accessing this. I can do EC2 instance dot property versus EC2 instance dot instances dot whatever that property might have been, because I'm pulling that in and defining that variable properly now. And so if we come over here and we look at the return, we can see that it's defined the way that I would have imagined it to be defined before. Oh, it kind of went away. So I can see the instance type and all the values there. I can see the name. And so if we let this completely run through, we now have all the data that we need. We've got the platform, the instance size, which is small, and then the IP address and DNS and stuff like that. And so that's just the power of the debugger when you're debugging functions, is you don't have to rip apart your code base to figure out what's going on with your code. Kind of take a minute and see if there's any questions. If not, we can move on. All right, we'll move on. So I'm going to assume that this instance is up and running. Don't worry, the hacker people out there, I'll delete this as soon as we're done here. So don't steal my password. I don't want to update you, Microsoft. All right. Let me grab some code for the demo. All right, now we're on my EC2 instance of Windows Server 2019. I installed VSCode for some more debugging fun. I'm going to go ahead and install the PowerShell function. So yeah, if you're not using VS Code, definitely give it a try, and make sure you install the PowerShell extension, because that'll get you the integrated terminal and all the debugging stuff that I'm going through right now. And you can change it to the ISE theme if that makes you feel more comfortable, if that's what you've been using before. So I know that's super tiny. So let's see if I can zoom in a little bit. All right. Is that font size okay? I think it's about the same.
Yeah, pretty good.
Okay. I could go maybe one bigger. Better yet?
Sure.
Okay. Let me turn off the mini map. That just, I don't know, it just annoys me. So I'm going to set my location. Trust the PowerShell gallery, because why not? And then the module that we're going to take a look at, so the previous two things that we just did was we've debugged a PowerShell function, and we've debugged a PowerShell script. And so now we're going to take it a step further, and we're going to debug a PowerShell module. So the module that we're going to be taking a look at is an open source module that I've written called Invoke DSC, and it essentially puts a JSON DSL on top of DSC. And so we'll take a look at, in particular, this demo, the function that I wrote to convert JSON to a PS custom object that Invoke DSC, the command that Invoke DSC can use. And if those in the audience aren't familiar with DSC, it stands for desired state configuration, and it allows you to define idempotent resource blocks and configurations for your infrastructure. So instead of setting a good example is like you want to create a file on a web server. With DSC, it not only would put it there, but it would test if it's there. And so that's where the idempotency comes in. So when you run it again, it can be idempotent. You can run it over and over without any impact or any errors. In a PowerShell script, you'd have to create like an if statement and a test path, perhaps, to make sure that it doesn't already exist. And DSC kind of takes care of all that for you. So I'm just going to download an example file that's from that module. I'm going to create that, and I'm going to create a configuration, a run configuration and configuration file, and then I'm going to add them to the editor here. And then we'll walk through the config in a second, so you have some context of what it's doing. Okay. So as I mentioned before, let me just can minimize the terminal here so you can see the code better. There we go. So as I mentioned before, what this JSON document does is it defines DSC resources, and so the very first block is called a modules block. And so this object in JSON, it basically just defines the DSC resource modules that are required for this particular configuration. So the only one that it needs that isn't built in is the X web administration module. There we go. And then I'm specifying a version of null. So aside here would be a version. If I wanted a specific version, I could set that here. Next is the DSC resources to execute, and I have two. So the very first thing that I'm going to do with this configuration is I'm going to ensure that the Windows web server feature is installed. And so the DSC resource name is Windows feature. So that's the DSC resource that I'm using to make this change. And then these are parameters inside that. You could do get DSC resource Windows feature to figure out the syntax of that, and it would basically just be a one-to-one mapping of the parameters in JSON versus a configuration document that DSC would use. And so the name of that value is web server, and then I want to make sure that it's present. If I put it absent, it would try to remove the feature. And then the next resource, this is just a custom name that's given, is DevOps app pool. And inside here, the resource name is DevOps app pool, and then the resource name is X web app pool. And this is a DSC resource in the X web administration module. So it's going to need that module to do this work. The name of the app pool, and then some properties that I won't bore you with. But basically, this is going to make sure the web server feature is installed, and then it's going to create an app pool for me. And so we're going to go ahead and just try and run a function in here. And we'll kind of there we go, got some errors. So before I dive into the error message, I'm going to give a little bit of context. So the invoke DSC module, so get module, so here, get command dash module invoke DSC. So it has several public functions. There's a convert to DSC, and that is what I said what we're going to debugging here. It takes the JSON format and then it basically converts that to a PowerShell object that invoke DSC can handle. And then there's some other helper functions in there, like install module from configuration we'll look at later. And then invoke DSC, which is a very basic commandlet that just invokes whatever convert to DSC gets it. And then there's invoke DSC configuration that gives you some more options and allows you, it utilizes that invoke module and tries to dynamically determine what modules you need based on your configuration. And so the chain of the process is it converts the object to PowerShell from JSON to PowerShell, passes that to the install module, installs all the modules you need, and then it eventually invokes the configuration and runs the DSC config. And that's kind of the pipeline. And so what we're taking a look at is the first function in that commandlet or in that module called convert to DSC. So we'll go ahead and run that again so we can see the error messages clearly. And so if we run up, we get two error messages. The first one is the term X web app pool is not recognized as a name of a resource. Now that's a good hint, but if we look down here, this kind of error is throwing me off a little bit. It says cannot index into an array. And then it gives me a specific line of the public function convert to DSC on line 42. So that's probably a good area to look at, and it even gives me a little snippet of that line. Get DSC resource with whatever this value is here is erroring out. So what I want to do now, if I'm going to take advantage of the debugger, is I want to open up that module and I want to set a breakpoint in that function. And I don't have to load up the whole code base, I just need to open that file. So we'll go ahead and do that. We'll run this line here. And let me just hide the terminal again for just a second, so we can see all the code. Or shrink it down. So here's the function. I put some help in there, so it's somewhat usable. Navigation is good. But if we go down to line 42, I won't go through all the logic here. But essentially on line 42, I'm expecting a resource name to not be null from the module. And then I'm using getDSC resource with whatever that value is. And then I'm sorting it by version, and I'm selecting the first one. And then I'm grabbing the resource name. And so without the debugger, I'm kind of blind as to what that is. And so what I'll go ahead and do is I'll set that breakpoint, and then I can come back over to my run function. So this is one of the differences between running a script and running with the debugger, our system output versus debugger, is you have to have some kind of program. If you're familiar with C#, you need something that's executing the code and then breakpoints in the code. So we'll go ahead and we'll hit F5 on this particular function, and it'll break on line 42 in that module. So I haven't even opened up the code base. I haven't had to pull open the module or anything like that, or pull on the Git repo. I can just set a breakpoint in the code base and start debugging from there. All right. So if we look at this particular value, we're on the web server. And if we step over this, we're not going to get an error because there's 2 times this block's going to execute. One is with the Windows feature resource, and then the other one is with the web app pool. And so the first one isn't going to have any errors, but the second one definitely will. And so if you look at this again, we'll kind of just click run because we want to get to the second run of that function, the second time that line is actually hit to find the actual cause of our issue. And so if we hover over this now, we should see that it's X web app pool, and that is actually the one that's going to error out. And if we step just over this one line, we'll see that we get that same exact error. And so at this point, what I would do is I would take this particular line in the code, because now I have all the variables loaded. I can actually just copy this line into the interactive terminal and run it, and make sure that there wasn't any kind of syntax errors with the rest of the statement or with the variables getting defined. I still get the same error. And now I actually just get one error. I get that very first one, which says the XWeb app pool is not recognized name of a commandlet or a resource. And I go, okay, well, what the heck? What I might then do is say, okay, well, because I have some working knowledge of DSC, I know that I need to have a resource module in here. I'm expecting it to be here. I could do GetModule XWeb administration. And we need to do list available, otherwise it'll hide it from us, and I don't see it. And so there I can tell that my actual issue is that I did not use the install module from configuration first, and I just don't have that module available for me, and that's why this is here. Now this is actually a good learning experience where I could actually put in a comment here or throw a more useful error than this particular one. Resource name property is null for this. I could say something like, the DSC resource for this module does not exist. And that would have been a way easier way to troubleshoot this issue. But now I can at least have dove into the code base, and I could navigate all my different variables inside the data that's being pulled in, and so forth. You can even see that XWeb administration's in the modules, but it was never called. So we'll stop the debugger. I'm going to go ahead and install the web administration module, and then we'll take a look at what the code looks like. All right, it should be there. We'll go ahead and just hit this again, and we'll let the breakpoint happen. So the first one is going to be on the web server, so we're just going to continue to the second pass. And then we can see that it's defined here, and if we wanted to, we could step into it and would go into the getDSC resource. And we could have done that too if we didn't want to interact with the command line. We could have gone into getDSC resource itself as a commandlet and found out that the resource name was null and it couldn't find any modules to pull from. But if we step over, we'll see that we don't get an error. And then from that point on, that was the only line we're concerned with. So we can click continue to just complete the rest. And we can see now that we actually get the proper results. There's properties inside the property object of convert to DSC. So that is how you could debug, or one way you could debug a PowerShell module. The last thing that I will show is Pester. And let's see, I think I had another window open for that. So if you've noticed, kind of the painful part with the debugger is you need some kind of script that's saved to disk that's not as easy as the interactiveness of the command line to debug. Granted, you could use the custom workspace stuff to set up something that attaches to your integrated terminal. You could debug from there. But it's kind of a pain to have to save a file, and you kind of lose that interactiveness. And that's where Pester comes into play. So Pester is a testing framework for PowerShell, and you can use it to test unit tests or integration tests, or even test your actual infrastructure state using PowerShell code. And so what I'm going to show you is a test that I've written for the module install module from configuration. So as I mentioned before, this whole thing, it uses a few other private modules, uses a function to private functions. It uses them to get the module version from the configuration. So in this case, it would have been the xwebadmin module in that configuration we looked at. And it's going to pull it in, and it's going to try and install that module. Now, when you're doing the unit tests, I don't actually want to install the module and put it on a temp directory. I can use something called mock, or mocking rather. And so that's what a lot of this stuff in this before statement here is doing. So I'm mocking GetModule. I'm mocking that private function that I had for GetModule from configuration. I'm mocking find module and install module. And what that allows me to do is to test the logic of my code without actually executing any other code. And the great benefit here is all the testing scenarios that I would do manually, like, oh, I made a change to invoke DSC module, let's test it out, run it at the command line and see if does it install with the version being null? Does it install with the version being 1.0.0? How does it behave when the version that I have on my box is more or is greater than the version that was defined in the configuration document? And all these scenarios that you would have to run through manually every time you make a change can now be captured in a test file and automated with Pester. And so that's the real value that I've found for Pester. Like I said, you can also test the state of your infrastructure. You can see if particular IS settings are the way that you want them, or if a file exists, and so forth. So the way that we invoke Pester is there's an invoke Pester commandlet, and then you just give it the path of a file. If you give it a folder, there's a key name or a keyword in this file called .tests.ps1. And so if you invoke Pester on a directory, it'll invoke it on then all the test files. But I am mainly just worried about this one particular function, so that is what I'll deal with. So it's in the test folder, and then inside that's in the public folder, and it's called install module. And so if we scroll through the output, there's different context blocks, and those are just basically groups of testing that you want. And so the very first one is no module needed, should write verbose message. And so I'm mocking write verbose in that statement, and I'm checking to see if the module outputted right. So basically, I'm testing a throw message in my code at this point, right? The next one, which has an error, says context no module version module exists. And if you look at the code that defined that, excuse me, here is what I'm mocking from the GetModule configuration. I'm saying that I'm using the XPS desired state configuration module, but I'm giving it a value of null. And so what I'm doing is I'm simulating what that commandlet would get from the configuration document given these properties. And what's happening is, for whatever reason in my assert down here, I would think that it would be installed one time, but the logic is a little bit different. It was called exactly 0 times, but I have 1. And so I have to kind of examine here why that might be, but I can also jump into the debugger. Oh, I got to invoke Pester on that with that breakpoint. And it'll jump me right into there, and I can see the variables. So if I look at install module config from configuration, I kind of showed you the code base up above, but if I didn't understand that, if I didn't want to look at that, I could actually look at the variables here. I think it froze on me. Let me start it again real quick. Local. Okay, it's in local. So I'm looking for script. I'm trying to think if I put the maybe I put the breakpoint at the wrong point. But at any rate, I'll figure that out in a second. By running this, I now have the ability to invoke it from the command line, and I don't need to save a file because I actually have a test that's calling my logic that I want to jump into. And I could actually, let's see here. Let's move the breakpoint there. I think that's where I'm messing up. There we go. So now that I'm in here, I'm actually testing the functionality of get install module from configuration. I can step into that and see what's going on. And so if we look at the input object command here, we can kind of step into the function. Keys contain path, and the path is null. Oh, there we go. So here, finally, it declared it. So what I'm looking from here is it's getting this from get module from configuration with these particular inputs. And the inputs are the PS desired state configuration, which we looked at before. If we step over that particular function, step into this, for each module, should define the actual module name. And so if we continue to step through this code base, we'll see that it skips over the block. Oh, it stepped into a mock. It steps over the block for the code base to actually install a module. So it should be changed from 1 time to 0 times because it never actually executes the commandlet install module. That's what I'm getting there. It's kind of a rabbit trail of code at certain points. But if we change that value, save the file, and then rerun the tests. Oh, I didn't clear all my breakpoints. Just click F5. We should get all green tests. So I apologize for that. That was a little bit of a rabbit trail, but essentially what I was looking for here is that I had the wrong times. It was 1 and needed to be 0 because the module had already existed on the system and I didn't need to actually install the module. So that is all I have, but I'm open for questions if anybody has any questions.
Hey, Josh.
Yeah.
What are good resources for learning?
So I heard good resources. Maybe I can pull up the chat.
Good resources for learning Pester.
The best resource that I have found is Adam Bertram's Pester book. That is by far, it's a little hard for me to read ebooks, but that was by far the best resource from an operator's perspective. There's a really good course on Pluralsight from Robert Kane on Pester, but it's very developer focused. And for me, coming from a systems engineering background, I struggled to grab the concepts with that content.
I would say too, if you're really trying to learn just the basics, like first exposure to Pester, check out the VSCode module. VSCode. Pretty good. Like walkthrough, it actually has like this meditation style thing where like it checks step by step. Takes all the assertions and like rerun the test.
There we go. Any other questions? Any feedback? Sold on the debugger? Not sold.
Question.
About dealing with threads and breakpoints, like is there any way to see what a
Sorry, I couldn't quite make it out. Would you mind repeating it, Joe?
Yeah, I was asking if there's anything you can do when you're trying to debug actual threads that are going on in the code.
So threads like PS jobs or run spaces?
Run space.
I have not used them, but I know Boprox has. So you can do everything that you can do in the actual debugger inside ISE as well. So you can attach to run spaces, and I've done it a little bit, but not a lot. I usually do PowerShell jobs just because it's simpler, and there's a commandlet for it, so you can jump into the commandlets. But you can attach with the custom configurations to different run spaces. You just need to figure out what that run space ID is, and you can attach to it.
Thanks again, John. Yeah, I think we're out of questions, man.
All right. Cool. Thanks for having me. I appreciate it. Thanks for the opportunity.
Chill broadcast.